Hello, how y'all doing today? My name is Bernie Thompson, and today we're here to take a look at a 2017 Jeep Cherokee. This Jeep's 2.4 liter engine is exhibiting a misfire at hot idle. So the first thing I really want to do is get a scan tool so we can get some diagnostic information on this vehicle. Let's get that scan tool installed. So we have the scan tool data up. The first thing we can see is we have a centered fuel and we're stoichiometric. The long and short term and total trims are all good. Time to temperature is good. The engine vacuum is good. Charging is good. I do not have a diagnostic code set and the monitors have all been run. So we have no codes, but I can feel this car and it's got a miss right now. Every now and then, it's not all the time, but I can feel the cylinder drop. So this car is missing, but we're not having enough misfires to break the diagnostic or the DTC threshold. Always remember, to get a DTC, you have to have enough misfires to fail your tailpipe emissions by 1.5% or 50% of the overall emission levels. If you don't do that and you're not damaging the cat like it's a hard miss, you may not have any codes. And that's what's going on here. The customer wants it fixed because he can feel the miss, but the scan tool's not giving me any help. So the thing I want to do is I want to go over to mode 6, and we want to go ahead and we want to go down and we want to pick Chrysler, and then we want to run it. And what I want to see is if mode 6 can help me any with what cylinder might be missing. So if we go down, here's our cylinder misfires right here, and we can see that 3 says I've got a miss and 4 says I've got a miss, and 4 has more misfires than 3, but 3 and 4 are both indicative that I have misfires. So at this time the scan tool really isn't going to help me diagnose this car. So what I want to do is I want to get a scope on this, and I want to get some data to where we can try to understand what's happening and what we need to do to fix this misfire on this Jeep. So let's get that scope connected. Okay, so I've connected the crankshaft position sensor to channel 1 yellow. Channel 2 red is connected to the ignition coil for number 1. Channel 3 green is connected to the camshaft position sensor. Channel 4 is blue, and that's connected to the injector for number 1. Channel 5, 6, and 7 are connected to the coils for cylinder 2, 3, and 4. So let's go ahead and start this thing up and let's get it misfiring so we can try to figure out what cylinder it is so we can try to determine where our problem is. Now that we have the connections made on this 2.4 engine, let's make sure they're on there correctly. If I open up the meter, I can see that all of them have signals except for channel 8 that's lit in red, and I'm not using channel 8 currently, so we're okay. So the first thing I want to do is I just want to figure out what cylinder is missing. So we're going to come over here and we've got our 1342 firing order. We're on number 1. So now what we're going to do is we're going to just get the data and we're going to just wait for it to drop the cylinder. It drops it every now and then. So as soon as it drops it, right there, we had it miss. So let's look at the data here. It'll come up and it'll analyze so we can figure out what cylinder we're even trying to fix. Okay, so here we can see that we had a miss on 4, and we can see this clearly drop down right here. Let's get the zoom window, and let's come in here and let me explain what we're seeing here. Each one of these is the crankshaft accelerating and deaccelerating, accelerating and deaccelerating. So when it drops, I'm deaccelerating, and we fired the fuel on the pink mark and it accelerated from firing. And then it deaccelerated. Do you see right here where we came down to 4 and 4 just flat dropped? 4 did not fire. So what we're looking at is a misfire on cylinder 4. So at least now I know what we're looking for. We're looking for a miss on 4. So what I want to do now is we want to open up the scope, and we want to use the scope and look at the ignition pulses and try to figure out which cylinder is missing. So we're going to come over here and I'm going to get data in fast record, and we're going to wait until it has a misfire. There, it dropped the cylinder right there. Okay, so this is the data. What I want to go ahead and I want to do is just to find where that happened. I'm going to process this data, and what we're going to do is we're going to look at the crankshaft velocity. We can see where the crank velocity changed right here, and that's my misfire. So the first thing I want to do is I want to come in here and I want to just look and make sure that this is still the same place that we had the misfire, that 4 is still the cylinder that we don't have, because 3 also showed a misfire, guys. So what we want to do is mark this. I want the ignition. We're going to mark it. Now we can see how we have 1, 3, 4, 2. This is 4. Do you see how 4 just dropped? The velocity of the crank dropped. 4 is my misfire. So I'm okay there. So now is what I want to do is I want to come down here and we want to look at this. This is number 4 right here, coil, and this is number 2. So we'll get these two and we'll blow them up so we can look at them. So, do you see how on 2? Do you see how I have a point of plasma? This is the arc, this is the spark event, and this is where we actually established the point of plasma right here. So we want to take a marker, and I want to mark the point of plasma. Then I want to mark the tail. The tail is this guy right down here. This is the burn, and then we shut off the spark because we didn't have enough energy left in the transformer to continue that spark. So the coil has to reabsorb that spark, and that's this first dropping edge, and that's this ringing right here. So let's do this. Let's just look at this one for a second here. Now, do you see how the point of plasma came across, and then we ran out of the plasma and it starts breaking down, and we have this upward rise from a breakdown of plasma. Then we drop, and this ring is the energy being reabsorbed back in the coil. Anything that couldn't be discharged across the spark plug has to be reabsorbed. This is the tail. So what's really important here is to see how long it took that burn to be established. So basically 1.79, 1.8 milliseconds is my burn time. And then we want to remark the tail, so when we go look at the other one, I can show you what I'm seeing here. And that's my point of plasma. Now is what we want to do is we want to go across and we want to find number 4 right here. Now we can immediately see that we have a lot of what looks like heavy turbulence. And right here, do you see this point of plasma, right, or the tail, I apologize, the tail is dropping. And that tail is dropping more, telling me I had more energy left in the coil, but that tail is still not that low. Usually when I have something where I really have a lot of energy, it goes well beyond the turn on. This is where I turn the coil on to saturate it. We shut the driver off and we fired the coil, or we collapsed the magnetic field across the primary collapsed across the secondary, making an output. Now I've got all this turbulent activity in here. Now what I'm interested in is, first I want to get the cursors again and I want to see how long this took. So here, this is 743 microseconds. It's under a millisecond. This happened really fast, and my tail is still not that low. If this would have gone across the spark plug and I had a short burn, this is what I refer to as time to tail. The time is how long it burned, to the tail how big it is. Well, this tail is too small for this to have gone across the spark plug gap. If this would have gone through the plug gap, this tail would be way down here, way below the turn on point for the driver. It'd be way low, and it's not, it's above it. Now I want to go ahead and we want to blow this up so we can see what we're looking at a little bit better. Now we can see where we had what we call the point of plasma, but this is way high. So this isn't the plasma like it's in the cylinder. We come across and we get all this turbulent activity here until we come down and this is the ringing, or the ring right here is where we're reabsorbing the energy from. So basically, this guy right here, this didn't go across a spark plug gap. Now you can see how it looks like this is turbulence, but that isn't turbulence, guys. What that is that's a carbon arc. So what we have here is the secondary has some type of a carbon arc down, maybe a spark plug insulator inside the chamber, you know, down the porcelain where we're down by the sparking mechanism. It could be outside the cylinder, it could be in the spark plug boot, but this is outside. This isn't making a plasma channel. You have certain physics that apply to making the current go through that plasma channel, and that has to do with not only the point of plasma, the time, and the tail. All of this tells me that that spark event did not happen across the actual spark plug electrodes, but it's going somewhere else. So what I want to do is I want to pull the plug, and let's take a look at it and try to figure out exactly what's wrong with this. So let's get the plug out. There it is right there, guys. I want you to look at this. Do you see this mark right here? That gray mark? That's arcing through that boot to the head intermittently. That's the carbon trace right there. So what's going to need to be replaced is this boot and the spark plug, and we'll get this car fixed. Let me get that spark plug out so we can look at it, see if we have anything on the plug. It's just coming out the boot, guys. So what's happening is the spark, every now and then, it's harder for that spark to jump across that electrode than it is for it to come across that boot to the head. What needs to be replaced, like I say, is this boot. We'll replace the plug as well. This carbon trace on this Jeep is being caused by a lean cylinder. In order to fix that lean cylinder, we need to treat the fuel, so the fuel going through the injector will clean that. In order to do that, we're going to use the 505 CRF. That's a fuel treatment. Now, this isn't like any other treatment that's on the market today. All the other treatments have polyethylamines, PEFs. Those are more prophylactic. They create a bond to the metal that keeps the carbon from being built on it. This will actually dissolve and solubilize the carbon, so this is very different, and it's going to fix this car. So we're going to go ahead and we're going to get this put in, and we want to add this usually to 1/4 to 1/2 a tank. And once that's filled, now this will be run with the fuel in through that injector. It will clean the injector so we don't have a comeback. Hopefully you've seen what we did here and the analysis that we did. This is a no-code spark. Sometimes these are very difficult to diagnose. Using modern technology with equipment that was specifically made to work on vehicles with, the scope just made this whole diagnosis so easily. If you're diagnosing in your shop, use a logical, thought-out process where you understand the test that you're trying to provide on the vehicle, and then complete that test and look at the data. Once you have that data, let that data drive the next testing event, and if you do this with quality equipment, you too will be successful servicing vehicles in your base.